Hi everyone, it's Nono here, and I want to welcome you to my live stream. Today, the first thing, as always, I'll ask is if you can hear me okay, if you can see me okay, and I want to thank you for being there. Today, we're going to continue where we left off last week. The main topic of last week was data labeling, as we'll see, and today's main topic is ML detectors, or object detection machine learning algorithms. My name is Nono Martinez Alonso, and I do this live stream. I try to do it every Thursday night, and here in Spain. And we cover topics from creative coding to machine learning to art and design, podcasting, sketching, writing, many different things we talk here, even embroidery. And we're about to start. I would invite you to join the Discord community. So you can go to a short URL at nono.ma/discord if you want to join. That just takes you to a Discord server invite. If you don't know what it is, it's sort of like Slack. It lets us have different channels and talk and share links and discuss our own projects. And without further ado, if you are there, if you connect later, or if you watch offline, I would invite you to write on the chat or on the chat channel inside of the Discord server and let us know who you are or what you're doing here, how you found us, and where you're connecting from. Thanks so much again for being there, and yeah, let's get started. So today we're going to take a look at data labeling. We're going to continue labeling with CVAT as we did last week. We're going to take a look at how to train YOLO v5 network. This is a state-of-the-art object detection neural network that we're going to try to use code from RoboFlow, I think it was, yeah. So RoboFlow is a platform for data processing, and they have a bunch of video tutorials and Colab notebooks. This is Jupyter notebooks that you can use with Python code that we can use for training our own algorithms. And we're also going to try to train a sketch detector. So we're going to try to use our data labeled, so our labeled sketches in this case, and train a YOLO v5 object detector. So before we get started, I would invite you to like the video because this helps other people find the channel, and also lets me know that this is the content that you're enjoying and that you would like to see more of it. And subscribe if you want to get notified when I go live next or when I upload new videos. And again, so the Discord community, there's a lot of people already there. There's a QR code and a link, so feel free to join. Last week, we saw data labeling, so we covered CVAT and labeling some sketches. We didn't complete that task, and today we left off those two items, YOLO v5 and sketch detector. Hopefully we get through today. Labeling is a task, it's an arduous task that takes a lot of time, but hopefully we get there. And this is a GIF I made, I shared online. This is me labeling a few sheets. It's slow, it's not super fast. And one thing that we could do is split the labeling job between different people. So we saw last week how to serve a CVAT server online on DigitalOcean. And that way you can create an account for your peers and your friends or some colleagues, and they can help you labeling data on their machine connecting to the same web server. Breathe in, breathe out. So this is a post, a short story that I've published and sketched this week, as always, on Tuesday. So that those are all at sketch.nono.ma. And also this week we released a new episode with James Meloni and Selene Urban on overcoming the fears of meditation, practices to do it and to breathe, authenticity, connecting with your audience, and more. Right? So if you want to learn more about their key learnings of their entrepreneurial journey and many things that we talked, go to the Getting Simple podcast and listen up. And today, so what we're going to see here on the channel, I would say nice to see familiar faces. Pedro, you're back. And, if there's other people online, just say hello and wave on the channel or on the Discord. So let's get started with today. So we have topics here, the CVAT labeling tool that we saw, the labeling sketches, and YOLO v5, and the sketch detector. So let's code. Let's see what we do today. I'm fresher than other days, I would say. So hopefully we get quicker through some of the things that we had to do. All right, so the first thing I'm gonna do here is I'm gonna try to get back at where we were. So I'm gonna open the Docker application to see what's running. And before I continue, let me go to the channel. So I want to say hello to Artur. I hope I'm pronouncing your name right. So he's just joining the Discord server. So this is a practice I'm going to try to do. So every time somebody joins the Discord server, I'll thank them and I'll mention them on the live stream. So Arthur is saying, let me bring this here. So hi, I'm Arthur, or Arthur. Hopefully it's Arthur and I'm not pronouncing it wrong. Hi, I'm Arthur. Just wanted to get some updates on the latest artificial intelligence and machine learning stuff. Got here through your very cool podcast. Thanks so much, Arthur. I'm glad to hear that you're enjoying the podcast and that you found the live channel and the live stream. All right, so let's get going. I was here and I was opening Docker. So when you open Docker, you'll get the Docker application up and running. If you're on Mac, you'll get this status bar item, and you can see that now it's telling us that Docker is running. We can see our Docker Hub account if we have it linked, and we click on the dashboard to open this application. We can see that CVAT is running. So this is a container that we set up on live stream number 21. Today's live stream number 22. And if you want to learn more about how some of these things work with Docker and DigitalOcean, you can go to live stream number 19. I haven't had a lot of time to crop video clips from past live streams and upload as separate videos. I'm hoping to do that and create playlists so you can learn and go through the videos at a faster pace in a more digestible version, so you don't have to watch 2 hours of live streams in bulk. But yeah, I'll point you to know how we got here, to go to having CVAT running and these 5 containers that we have here running. I will point you to live stream number 21. All right, so CVAT is running, and we can see that the port that is being mapped is localhost 8080. And hopefully, if I go to Google Chrome, and yeah, Arthur, I am happy that that pronunciation is right. And yeah, I just wanted to welcome you. I really appreciate people who pay attention and are interested on the same things that I am. So let's take a look here at the URL. So we go to localhost 8080. You can see that already there is an application running in here. So I'm going to put this on full screen, and it already logged me in. So last session we created the live 21 user, and you can see what that means and how to do that on that video. If I log into here, so live 21, and then sign in, then I have access to my projects and tasks. We only had this Sketches project that I created 7 days ago on last week's Thursday. And if I click here, I can see my tasks. So I can open a task or just go to tasks and then open. And you can see there are 54 frames or 55 frames, I think, with 55 sheets of scan drawings that I have uploaded here. So if we click on, if you click here on job 5, we open the task. So this loads the current state of the project. I don't know what's going on here with the UI at the moment. Let me try to figure it out. All right, so let's close the task. Let's go to tasks again and reopen this. It seems like I was zooming in a weird way. All right, so now when we put this on full screen, I'm gonna go here to the right and just make a quick review of what's in here. So we have 2 labels. One is drawing and the other one is text. And I thought that we could also in here actually we could also create more labels. So another label could be for the arrows. We mentioned that last week. We have a lot of these arrows in the drawings. And another label that we could also put in here is full drawing with its label. That's something hard, but it would be as if we were to create a label, for instance, for this, that will be not only the drawing or the text, but the drawing and the text and the arrows, right? Like everything, or the lines, right? Not the arrows, but the lines. All right, so here we're going to remove this label. And for now, we're just going to continue labeling the data set with text and drawing. So we're not going to add any extra ones. So we've labeled 1, 2, 3, and we're here. So I wish I had this done and we could just scroll to the next part, but I'm afraid that if we don't create more, if we don't add more labels, we're not going to be able to train properly. So I think this was in N, so N for new, I guess. So I'm selecting sketch here, right? Like I'm clicking, so you know how this works, and you can try it on your own if you set up your own CVAT server. So I don't have anything here, so I press on letter N, and then I get this thing. So if I press N, that gets deactivated. I press N, I click here, and then I move, and then I click here again. And then I go here, press N, click here, and then click here. So I'm gonna try to do a few sheets so we make sure that we have some labels that we can then convert to the YOLO v5 format and and go from there. So if I label now, I guess I'll have to click here on text and then. All right, so yeah, I've changed labels now. So I'm labeling with the text label, and I can zoom in here. Note that this is sort of pixelated. I created a lower resolution image for to make the images lighter, but also when we go to our tasks, what CVAT does is that it tells us the image quality at which we are rasterizing the images on the or previewing the images on the task editor, on the labeler. All right, so I'm going to do this, and just to verify, for those of you who are connected online, I would ask again, can you hear me okay? Can you see me okay? Is this lagging? Is this fluid? Does it sound okay? All right, so let's keep going with another round of labeling. So we're gonna do text. And probably here, something that is super important is to get to know the shortcuts. All right, so what's going on here? So N is for creating new labels. And I don't know how to see the active label. Right, so F is to move forward, D is to move backwards. V moves you 10 to the right, C moves you 10 to the left. I'm just trying to figure out just trying to figure out the commands here. So this we can remove. How can we remove this? Yeah, I don't even know when I locked this item, but let's see. Sounds and looks great. Hi Rob, nice to see you online. So Rob has been sharing a lot of interesting links on the Discord server, and also sharing some of his own posts and contributions on LinkedIn. All right. Cool. So we'll go forward, and this one is a tricky one because the entire page is a drawing. And now again, I don't really know how to change labels while I'm doing this, so I have to do this manually. But there has to be a good way to change the label. All right, so here, drawings. You know, another thing that we could do probably is create a little script that crops our drawings, and then afterwards train a classifier on something like Low or ResNet or MobileNet, right? Train an algorithm to recognize what each of the images that we're labeling is, right? Or each of these boxes is like an image recognizer. A detector, the only difference with a detector is that it will also propose bounding boxes and tell us where each of those things are. Right? Great. Cool. I think I'm a bit slow with this, but you know, would somebody be willing to help if I put this on CVAT online? Would somebody be willing to help and maybe try to, so we collaborate and label a few of them? That would be good. We can do that. All right. So, or maybe while I train. But yeah, that's okay for now. Also, if you know of somebody who would be interested on helping me with the video editing of some of these tutorials, I have all the projects inside of Descript or Descript, and I just need to create the markers for the episodes for each of the live streams, and after that making exporting different segments and then re-uploading to YouTube as individual clips. All right, so what do you think? Should this be an individual symbol? Okay, so how do we get to swap labels quickly? So shortcuts. All right, so we have shortcuts here. So blah, 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 go to next frame, previous frame, go forward with a step. Repeat the last procedure of drawing with the same parameters. Activate mode to merging shapes. Switch automatic bordering. Where is it? Go to next attribute, attribute annotation mode. Go to the next attribute up, go to the next attribute down, go to the next annotated object, go to the next preview, assign corresponding value to the current up arrow. Let's see if that makes it. So I have here up arrow, up arrow. No, really? That has to be color by label, instance, group, opacity, outline borders, show bitmap, show projections, appearance. Attribute annotation, tag annotation. Key one. All right. So just discover something. So standard, we label here by label. So display things by label. We're gonna delete this thing. Oh, we're gonna remove this label. Okay, so what I just saw here, I didn't really know about this before. So let me go to the left here. So there are some modes here. I didn't know about them. So we have standard, attribute, annotation, tag, and review, right? So if you click on standard, we have the UI that we had just now. And review, probably you just want correct position, just kind of provide feedback about what was labeled in case that somebody's reviewing this for you. But if we go here into tag annotation, that is what I'm doing right now. We have these tags, and I could add a new one. So we could add tags here. So frame tags. So let me see. All right, so tag label. Tag annotation. I don't understand what this is. Attribute annotation. No attributes found. All right, standard. Standard is to create labels. Yeah, so the number key doesn't work on the standard mode. So by 2 points. So let's see. So here I have Shift N or N to draw again. So Shift N. Yeah, I'm really not sure what's going on with the UI, but you know, if somebody figures it out, that'll be good. I'm not gonna spend time right now trying to figure out the shortcuts, just because we don't have a lot of time and we have to get to the YOLOBFI part today. All right. If anyone figures it out, tell me on the chat or tell me on Discord, and I'll be happy to see about that shortcut. Looks like it's not implemented yet. Arthur just added a comment. Looks smooth. Sound is also okay. Awesome. Great. So add shortcuts for changing the current label. This issue is really recent. Where a label should be changed. You select the polygon drawing method specific label. Label several objects in image using N. Then select a new category. Continue labeling objects in fashion. Well, we'll just give it a plus there. It seems like it's not implemented yet, but not sure. So tag, annotation. Annotation mode, attribute mode. All right, one more time. Let me just try this. So add tag, frame tags. Yeah, I don't know what this is. Okay, so I guess, you know, what can be faster, I'm going to just look for drawings first, and then we're going to be labeling text. So probably that's going to be the fastest. So we're going to be drawing here, drawing here, drawing here, there, and here. Now I press F, and then I keep labeling. There you go. There. All right. Yeah, this seems a lot faster, definitely. More. These are failed attempts at sketching my grandma. All right. You know, these ones are going to be a bit tricky, I think, because, you know, my style of drawing, I leave a lot of white space. So I don't know if the algorithm is going to know to keep all those together. But, you know, we'll see that. We won't have to worry about it right now. All right. You see, sometimes it takes longer to figure out like the thing of how to swap labels than to just label this however you can and then chain tags and come back to the thing again. All right, so this is going to be another challenging one. Fantastic Spanish omelette, tasty. And this one here, that one. Well, also, while I'm doing this, I will remind you, like, oh, and hello, Bea. Nice to see familiar faces again. And if you have any thoughts, any comments, or anything that you're curious about of what we're going to be doing today, let me know. Ask on the Discord server or on the chat. Okay, we're going to label these ones. And let's see, so we're at 14 drawings. How many should we label? Maybe get to 16 and then do the text and then try to train YOLO. So the overall story of what I'm trying to do with this is I'm trying to train an object detector to be able to get some information about my sketchbooks once I scan them. The number of the image, so this is image 15, so 15.jpg. This is a high resolution scan of an A4 page on my sketchbook. And what we're trying to do is, you know, I would scan my pages from time to time, then I end up with 60 pages per sketchbook, or in other sketchbooks a different number. And we want to make sure, we want to try to automate the process of cropping those and understanding where drawings are in the page, on the page, right? So we could maybe do some automatic cropping, some automatic editing, and try to streamline the process or automate the process that I usually do manually with Photoshop or other image editing tools. All right, so here okay. All right, so what else? So we have 17 here. All right, this will be the last one. So we're almost done with the part that we're gonna do for labeling the drawings. And I'm gonna go back to the moment where we stopped labeling. You see how fast we went by just labeling everything that is drawing, and now we are going to do the same just with texts. All right, and I hope everyone's having a good week. So mine is gonna be a bit shorter than usual, and I was looking forward to this, so I wanted to finally get to do some data labeling, and hopefully we can train the YOLOB5 network and see some results. I don't know if we're gonna be able to see some results today, but hopefully we will. I would also ask you if you have in mind any potential data sets that you would like to label and train a classifier or an object detector on, and what tasks would you like to automate or to try to do a task and perform it with a neural network for object classification or so object detection. And I feel like at least on this sketchbook the lines are showing up really often and could be something that we also end up labeling for. Right, let's go to the next sheet. So again, to remind of the shortcuts, I'm pressing F to go forward, so we'll go one frame or one page in this case forward, and I'm pressing N after selecting on this menu the right label, so I'm pressing then N, because N is repeating the last action. It's not actually creating an annotation, but repeating the last action, that in this case is always creating a new annotation with the right label. And I'm trying, I'm not doing perfect labels, but I'm trying to put them as tight as possible. So then what we get is also tight and accurate. And I think it's better, well, I mean, the more labels you have, the better, but also if you have fewer labels that are more accurate, that's going to be maybe better than having many labels that are not accurate for obtaining greater accuracy. And hopefully we can end up labeling the rest of the data sets by automating with the model. So next sheet, more of this. Here I'm going to put this one as one separate one. And then this one here. These are two different blocks. All right. Okay, I think, oh, we're still at 12. So this is something to learn from, right? If we say, okay, we're gonna label the drawings, but instead we say, okay, let's also label the text and then the arrows or the lines or whatever. You can see that I label the drawings fairly fast, but now I have to go sheet by sheet looking at the text, and I would have had to spend more time if I wanted to also label not only the text and drawings, but the text plus drawings together and the lines and other things, right? So every single thing that you do that you add to the labeling process is going to make your labeling process slow, of course, but a lot slower, because even if you think it's not that much time, you'll have to label each sheet multiple times, as we're doing now. So we're at 14.jpg, and let's see. All right, we're almost done. That here, this date. And for the consistency of the dataset, we could even label text and dates differently, because I think visually the dates are really consistent. Right, next one. So we go here, there, we go there, here, there, here, there. Okay, we have two more. So we're gonna do this one, that one, this one, this one. Yeah, I'm not sure if these logos represent text or not, if that's gonna confuse the detect your network. Note that I'm leaving these arrows out, or those lines out, because those will be better included on the lines label. Okay, I think I just did something I didn't intend to do. I went one sheet forward, right? Yep. All right, that's there. All right, we're almost there. And for whoever is connecting that wasn't here before, drop a message on the chat on YouTube or join the Discord server and let us know where you're connecting from. I see familiar faces, so Mamadou Kali, so hi, nice to see you around again. I'm glad that you connected. I saw your message on the Discord server that you were watching past live streams. Today we're continuing with the tasks that we were doing last week. So hopefully we can train an object detector today. I'm not sure if you mentioned last week where you found the channel and your background or what you did. Maybe you did Oregon. Was it Oregon? I don't exactly remember. Orlando, Oregon. All right, so this one is labeled. So we're gonna go back. We're gonna put now the text label shape. So this is text, sugar, chamomile, hot water, spoon, PS vase, there. Right, and one more. Text, once more, text. Right, so let's go. We can see now, we can enjoy the fully labeled 20 images, right? So we have here, that one. And imagine how cool this would be if this was automated, if this was actually made by the neural network and not by us. All right, so we have this, so now we're gonna go above here and press on save. So we save the task, and now we go to tasks. And here, now if we open our task, we have a set of actions. So let me see where I'm at, so I can go to the left. And the thing that we're gonna do in this menu is we're gonna dump the annotations, right? We can export as dataset, and we could export as, let's try YOLO 1.1. We're gonna train YOLO v5, which is not made or developed by the same developers that or scientists that developed YOLO initially, darknet. And what do we have here? So we have trains, we have all this data. Yeah, and we have a set of labels. From YOLO, we have, let's try to understand, let's export to a few more formats. So we export also to COCO. And we export also to, well, we could do TF record, but we're probably not gonna use TF record. All right, so we have this data set here. And COCO 1 has annotations and images. So the images are the ones that we are seeing. And the COCO format is here, which is, it's a JSON file that might be also easy to parse. So we have all the images, image 1 up to, so if we, let me go to the right. So if we collapse the images here, we can see, so we have licenses. Yeah, so we have info, categories, images, and annotations. So we saw this last week already. So licenses, we don't really have anything. We don't have any info. Categories, we have the two labels. So we have drawing and we have text. And under images, we have images from 1 to 55. So we have 55 images. And that captured, blah, blah, blah. And then in annotations, we have a bunch of them. We already, this is crazy that we already added 250 annotations. And, you know, parsing this JSON file, we could easily take a look at which ones of the images that we've labeled doesn't have any annotations, right? Or which ones we haven't labeled. So this is a COCO format, and this is the YOLO 1.1 format. If we go to the training data, we can see that many of the files are empty, so we haven't added any labels to them. But if we go up for the first 18 or 19, we do have information. For the TF record information, we have a label map, which is a proto file, PB text. And this is going to be opened by Netron, which probably not the best idea. But we can open here. So we have drawing and text. So that's the proto file. And then the TF records, which if we process with TensorFlow, contains the same dataset that we've exported before. All right, so let's now try to figure out what we've done and where we have to go next, right? So we've seen, or we mentioned before, that we were going to, you know, we've been labeling. So I've been labeling different things, and we already have 18 or 19 images labeled. So today we said we were going to do data labeling. So that is done right now, at least what we're going to do for the moment. So we're going to go and check this off. And we are going to take a look now at YOLO v5 training. So what YOLO is and how we can train and how we can prepare the dataset. There is a step here that probably I'm missing that we're going to add right now that is called data preparation or dataset preparation. And And yeah, we'll add that because that's also important. So we are, this is my process that I'm incorporating into the live stream, because this is also helping me keep all the video thumbnails up to date. So we've done data labeling, and now we have to do data preparation or data set preparation, right? So we can mark here the data labeling as done, and we'll update this thumbnail later. So we can, maybe we leave this closed for now, and we still have the CVAT thing open. So maybe for speed, we can stop it. So we could stop the CVAT container here, and that stops our server. And now, this thing dies, and we can even close, we could even close Google Chrome if we wanted to, but we're not going to do that right now. All right, so I'm going to go back to the this first slide. And yeah, so I will take a second, to say hello to Lourdes. Hello, Lourdes. Thanks for connecting again. And Mamadou Kali saying that, yeah, Oregon, Portland, I'm new to machine learning. I first found your video on how to implement TensorFlow on AWS SageMaker. I like your content. Thanks a lot for that. I'm glad that you found us through SageMaker. It seems to be like it's a highly technical material, right? So there are some live streams on SageMaker, and also some tutorials, specific tutorials that cover materials on how to train your custom TensorFlow algorithms on SageMaker. So if we go to the YouTube channel and go to the live stream playlist, there is one that doesn't really have a good cover, I think. And that is around here. So I don't know if this one is also the same, but yeah, so around live number 8, which we spent 4 hours connected and I almost didn't have any hair. There's a lot of stuff that we did training on SageMaker and seeing how the different types or the different ways in which we can train with different machines. And we also did a Q&A, and yeah, so you can go there, see that. And if you go to the machine learning series playlist, there are 2 videos that I uploaded. This is train custom TensorFlow algorithms in SageMaker and the hands-on coding part. So it's a 2-part video, and this one covers all the particular things on like how you have to build the code, what it means to train on SageMaker, and so on and so forth. All right, so getting back here, so we're gonna do now data preparation. So we've labeled the sketches, and YOLO B5 dataset prep. All right, so I'm gonna take a really quick break. I'll also give you a chance to ask any questions that you might have for me. We can do a live QA in between sections, or I can answer questions that you might have of what we're seeing today or what we've seen on past episodes. So let me see if I can do, maybe we can do here a break slide. So this is, so you see what I'm doing with Keynote, because I didn't know another way to do it. So break. Yeah, so for example, if we put here break, right? So this is this has an effect. So the effect here is, this is a hidden slide. So the effect here is this one, right? So a really nice feature that Keynote has is to export now to GIF or movie. So if I don't put any delay and I export slide 1 as a break, right? So now I can copy this slide, maybe put it here and hide this one, and replace this video with that one. Right, so we get that background color. Whatever. All right, so now we have this break slide. All right, and I will be back really soon. It's gonna take a water break, stretch a bit. All right, we're back. Hello, and glad to see some familiar faces. Jose Luis, welcome to the live stream. We were, for those of you who just connected, I see that there's some more people online. So the parts that we're gonna cover today that we've gone through already are the labeling sketches dataset. So this is already something we've gone through. And now we're going to go through preparing a data set for YOLO v5. So actually, I'm just going to introduce this as a new video for when we edit. So CVAT is running right now, and I'm going to introduce this now. Hi everyone, it's Nono here, and this is a quick tutorial on how to prepare your data set for object detection labeling with YOLO v5. We have trained a dataset, in this case, a dataset with sketches from sketchbook scan with CVAT. CVAT is an open source data labeler that allows us to apply tags to images or bounding boxes with tags and other types of labeling. And we're gonna briefly see what it is, so you I'm very blurry. Oh, right. 1 second. What's going on? Okay. Things of the autofocus. Thanks so much for letting me know. Is this better? Jose Luis? Everyone sees me okay now? Is it better or a lot better? Problem solved? Thanks of live streaming. All right, if you guys give me the final okay, I'll get it started. All right, great. This is what happens when you're live, and thanks so much for being there connected, because otherwise I wouldn't have realized. I just had to turn off the autofocus feature on the webcam. All right, let's try this intro again. Hi everyone, it's Nono here, and we're gonna see a quick tutorial on how to prepare your dataset for YOLO v5 to train an object detector. We've prepared a set of images that are labeled with object detection bounding boxes, in this case labeled with two labels, drawing and text. We've used CVAT, that is an open source labeler. We have it running with Docker, and we can open it on my machine right now if we go to localhost 8080. And there, we're already logged in. There are other previous videos that will show you how to get this up and running on your machine or on a remote server, and how we've done the labeling process. To give you a quick example of what we've seen today and what will be seen in previous videos and future videos, we have this dataset labeled already here. So we have 19 images so far out of 55 that are labeled, and we're gonna try to train YOLO v5 with this data. Each of these is a bounding box. We could move them or we could create new ones. And hopefully this is enough for us to train a classifier, an object detector that works sort of okay. If we go to images that don't have any labels, we could start creating new labels like this and adapt what label the image actually has, or the bounding box has, right? So I'm just gonna label this to have it on this tutorial for illustrative purposes. And this is we have a previous video entirely on this. It's also on live stream number 22, and you can see some of the things that we have gone through to kind of learn how this works. Some things involve the command to create new labels, how to swap the different tags, like we can use D and F to go back and forth, and so on and so forth, right? So we save the task, we go to tasks, and then we have this task here that already has some labels. And I think if we open the job and we go here to information, we get to see that we have 55 frames and we have 111 drawing labels and 149 text labels, a total of 260. And here, there are 3 tags that I think I added by mistake. That wasn't really my intention. I think if you go here to tag annotation, we can see that some drawings, these 3 labels or tags here were added by mistake. So that's a good tool to let you debug your data set and know what you've already done or what you've gone through. All right, so now here on the data set, so we have these tasks, and what we will do is first we export our data set. There are many formats, and one of the most common ones are, well, CVAT has its own format to export labeled images and video, but one of the most common is COCO. COCO is a standard annotation format that is actually JSON, and it has a format that we'll see right now that is compatible with many systems. Another one is YOLO 1.1. It's also a standard, but a different one. And I think we're going to stick with YOLO 1. So with COCO 1.0, because we'll write a converter for that sort of data. So I already exported those, but we're going to export again. So I'll delete all of the ones that we had from before. I'm going to go here, export dataset, click on COCO 1.0, and then we'll see on the bottom left of my screen, we'll see a download being downloaded there. So this is downloaded actually from the web server that is being served on my machine into another folder in my machine, which is a bit weird, but that will work if you have CVAT running on a remote server and you want to download the samples. As a recap, this dataset has a reduced resolution version of my images. My images are high resolution scans. We can see them here. So we have the pages in full that are, around, I'm not sure if this is going to show right now, but if I open here, it's like 11,000 pixel wide scan, but I'm using these ones that are, instead of 11,000, are 2,000, right? So I reduced already the pages probably to 50%, I think, or no, not 50%, let me see here, to like 20% of the original size. We can see here that CVAT is reducing the quality to 70% when we preview. You can set that to lower. So for example, if we put the original data set, we could set CVAT to do and use images at 20% of the original. So we could use the original 11,000 images, but then have a lower resolution preview here for faster loading and processing. But for the purpose of now, we just have images that are around 2,000 pixels wide. So we've downloaded the dataset and we have that here in this folder. And now we can go and close CVAT because we've already seen that. So we're going to close the CVAT server, and to make the computer run faster, I'm going to close Docker as well. And we're going to explore the COCO dataset. So COCO dataset, we're going to remove this zip file, or maybe keep it just in case we break something. So we have this folder, and then we have two different folders. We have annotations, and then there we have images. So inside of images, you can expect to see just the images. So these are 55 images. You can see the resolution here, 2537, the same that we saw before. And they have the original names, right? From 1 to 55 or to 60, there are a few missing. And then in annotations, we just get a JSON file, right? That looks a bit messy. But if we open it with Visual Studio Code, for instance, or like Sublime or Atom, or their editor of choice, we see a JSON file that is pretty well structured. We're gonna collapse these sections and we'll take a quick look. So we have here licenses, we have info, we have categories, we have images, and we have annotations. We have licenses that is empty, info is also empty, we haven't put anything there. In categories, we have the labels. So we have the drawing label and the text label. These are the ones that I created. There is no parent category there. And then on images, we're gonna have from ID 1 to ID 55, we have all the images here. The only thing we get is the name, the corresponding name of the images, and the sizes. And we could also see like a license ID, when they were captured, and then if there is a COCO dataset URL or a Flickr URL. That's what this COCO annotation format standard has, right? So that's for the images. And then later on the annotations, as we saw, we have from ID 1, we have 260 labels. And one thing to note here, different to COCO, also to YOLO, is that this dataset or this format has absolute pixel values. So this is a bounding box that is at 2044 pixel, 645, and then this is the width and the height, I think. So if we go into Google Chrome and we go to the COCO annotation format, COCO dataset format, right? So there's a set of things and we get a set of bounding boxes. This is the same thing that we just saw. We saw the info. We are seeing the licenses. We could have licenses for the images. We have the images that, as you can see here, apart from the file name, you also have the Flickr URL just to know, have a reference to the original one. And then we have the categories and then the annotations. And this is what I was expecting to see, right? So we have the bounding boxes, and what I want to see is what the bounding box corresponds to. So X and Y, and then width. Bounding box, X, Y, width, height. I think that's it. And create submask annotation, find contours around each submask. There could be multiple contours, is partially occluded, blah, blah, blah. Pull it all together. Import JSON. Right. So this is for a different thing, but the first thing that we should do is try to draw the bounding boxes and make sure that what we are seeing on that file is something that we can render and that we can process, that we understand this bounding box coordinates, right? All right, so let's try to do that. So let's close this one that we had here before, and what format or what language we can build this on, Node or Python. Let's do Python. That seems to go a bit more with the other things that we've done on the live stream. So let's go to the desktop, and or maybe let's go to the live stream folder. Let's make a folder for live 22, and let's run here Jupyter Lab. So let's run a Jupyter notebook. All right. So we're gonna make a script to process the data set that we have right now in COCO 1.0 format into whatever YOLO needs. But first we need to understand a bit the data that we're running on. So Python version, let's see that first. 2.7, that's not what we want. Maybe this is Python 3. All right. So if we did, for example, here import from pill. All right, so we have pill, and let's first go and get the path to this. So we have annotations. Where is this path? So I'm gonna copy the path here. So this is, if we press Alt, we can see here we can copy the path name. I don't know if my face is in front of it, but here, path name. So I'm copying the path name of that directory, and I'm putting here COCO there. We just put that one here. And what we're gonna do is that we're going to, let me just try this. So glob COCO there. All right, so yeah, so we have access to that folder, and what we're gonna do is import POSIX path. Let me just look for something. POSIX path. All right, so With this, we get like a path, and then we can get also the OS library, and then we do things like OS path, join, and then COCO there, and maybe images, right? So for instance, we get the path to the images, and then we get the path to the annotations here. All right. And again, I'm gonna get here to the left. Are there any questions so far? Any doubts or any things that you might be thinking that we haven't looked at? All right. So what I'm gonna do, I'm gonna clean this up a bit so we know Pill works. We're gonna move our imports here at the top, and I'm using a Jupyter notebook for fast development, but you know, we could just have a plain Python file. And import glob, we might need this or not. I don't really know if we're gonna need this. So we don't need this, we don't need this, we don't need this. All right, so images there and annotations there. We're gonna put this here, there. All right, so we don't need this one. Okay, right, so well, we need this one, we'll get it later. Right, so this is all we have right now. So we have our COCO there, our images there, and the annotations there. So we have those 3 paths. And what we're gonna do right now, we're just gonna try to import. So I'm gonna do here import JSON, and I'm gonna try to get the path of the annotations file. So let's see what we have. So on downloads, in annotations, we have the instances default. All right, so I don't know if that's a standard all the time, but we're gonna get that annotations JSON. We probably just put here this thing. All right, so and then JSON load annotations JSON. Red. All right, so let's make a refresher. Load JSON file Python. Do I have an article on that? Load a JSON file with TypeScript. Not really. Nope. All right, so read and writing to JSON file. Read, load. All right, so we gotta open with open. Okay. Open. All right, so first thing we do here is can I just open the file? Annotations JSON. Right, what is this then? Okay, so load file. Okay, so as JSON file, load data. Yeah, okay, so let's just try it. Load. Okay, so we got that. So our annotations are here, and then we can request, for example, annotations info, right? All right, images. Great. Cool. So I think, so I'm not sure if I can just do a dictionary. Nope. Let's do for image in annotations, print image. Okay, great. And I could do image width. Great. Okay, so we have here the paths, which we don't really need anymore. We just have here the file, so we could also just do that. And then we have the images, and then we have the image file name, I guess. Image file underscore name. File underscore name. Great. Okay, so we have the images. We're gonna here just put an index and make sure we just print a few of them. right? So we just process the first 5 images, and we're going to do the same for the actual annotations. So annotations, and we don't have maybe a category. So category ID, right? Category ID. Cool. So here we can get, I don't know if so the labels are defined on the annotations file. So we can here get, so categories, categories is going to be a dictionary. Well, we can just do it like an array, and then we can do for categories in annotations, categories, we can first print the category. Yeah, so we have drawing and text, so we can get the name, and we can say categories, append this. For now, we don't need anything else than that. So here in categories we'll get drawing and text. So here we can say this is category ID, which would be categories, and then we'll access with that. So yeah, so here we have a set of bounding boxes. So right now we're going from this file here. So we're and once again, let me just put it here so you can see it. Let me just go to settings. How can I go? Settings, font size, preferences, open UI. Right, so font size, let's just make this 24 right now. Right, so this is nice because this makes the UI stay the same, but the font size bigger, so that way you can see it and we don't see everything like super zoomed in. Okay, so categories. So we're getting these names, right? And if I were to put here something different and we rerun the entire thing, you can see that that's being read from the file that we've exported from CVAT. And nice. So we have here the categories, we have the images, so we can render or load the images and see which ones they are. And then we have the annotations. So the objective here is we're going to get those labels, right? So the labels that we had from before. So we're going to get these labels. So we've been labeling. So we're going to get those labels and the image and the name of the tags. And we're going to try to display the images first. And then we'll try to also render those boxes there to make sure that we're understanding the bounding box coordinates, right? So let's go back to our cover here. So we had that one, and this one. So first, let's render the images. So we can say image equals image.open and then image file name, right? So file name equals that, and then here we can put file name. These won't work, right? Because we're just have the name, we don't have the path, and for that is for what we have the images there. So this directory we can say os path join, and then we put the images there and the name of the image. So now we can open the image. And I don't know if we can print an image here. Yeah, we have the images, and then I guess we need matplotlib, but for now let's just return one image here. Can we do that? Yeah, okay, so we're loading that image here. Okay, so let's get matplotlib import. So import matplotlib plt as plt. Does that work? Matplotlib plot as plt, right? pyplot. Pyplot. All right, so that works. So let's just try plt show image. Yeah, so it's only showing the last one because we need to. Okay, right. Cool. So we're loading all those images. You see, it takes time because we're actually loading the files from disk into a NumPy array or like whatever pil image is doing. And we might not want to display, so maybe we do resize to something smaller. And that may, yeah, that's making them square. So yeah, okay, whatever. So let's plot them as they were square. So we have those images like this, and we can also do PLT axis, I think, off, so we don't see that. Great. So yeah, so we have a few images here. So let's make this a bit smaller. And now we're going to try to plot draw, I never remember. So draw bounding boxes, image Python. I don't know if OpenCV is better for this or we can do with Pillow. Okay, image draw, that was it. So we're importing the image draw component and we get to draw, all right, so draw that. Okay, let's actually just get one image. Let's get one image here. Let's get, and let's make it a bit bigger. Figure size, I don't remember. I'm sure we have a lot of examples on previous live streams on this, but it's been a while. So plot 1 1. Okay, so let's see if we get to the interesting part and get to the YOLO training before we prepare the data. After we prepare the data. All right, so let's see, padding and max pooling. All right, maybe something with Bill here. Nope. All right, so let's just keep moving. So let's not resize the image. Can I do this? No. show. Okay, so I guess this opens the image on a desktop viewer. All right, yeah, so this does that. And I guess we could use that for debugging right now. So let's just do that. So we don't need to resize. Oh, it does take a lot more time. Okay, so we have this here and we have the bounding boxes. So how can we do this? So we can probably process the images. So we have, yeah, so we have this image, and now we want to loop through the annotations. So here we have an ID. So this is image ID, I think, right? So print ID, right? So this is image number 1. And then we want to loop through the annotations. And we're going to see if annotation. So we'll print the annotation here to make sure we don't use the wrong keys. Right, so we have the category ID and the image ID. So if annotation image ID equals image ID, so we'll put here an image ID. We'll okay, if it's not equal, we'll continue. Right, so all right, so for this one, for this image, we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 7 labels, right? So we are going to print, so the bounding box is going to be the annotations and then the bounding box, and then we'll print it. Right, so we have our bounding boxes here, so this is looking good. So we have 7 drawing bounding boxes, for example, and we can now do an image to draw. So we can do a drawable image with this model here. So let's make it bigger. So we can open an image that we already have done. We can make a draw component, and then we can draw lines. Or we can, we can also draw polylines and stuff. But let's just draw a line first. So we'll do here, so we'll do here draw, image draw, and then draw our image, right? And the first thing we're gonna do is we're gonna draw a line from 0, 0 to 1000, 1000. Let's just try that. And then draw show, maybe not. Image save as IM. Okay, so we're actually drawing on the image. So image draw is not defined. Okay, we gotta reload. So I've executed this cell again, right? Right, so you might not see it through the live stream, but there is a white line here that we've drawn from 0, 0, 0 to pixel 1000, 1000 that is here. So that is working now. So I guess I can give it a field color. So it's different colors. So we put that in here. So field 0, and I guess we can also give it a stroke or something, right? So our line is there. So hopefully you can see it. And let me see if I can give it a stroke or something. So stroke width. All right. So stroke width is going to be 10 now. And here I'm actually gonna, so let's say, so if we resize, so we can say image width, so height, so width, so let's do width equals, image width is going to be 512, and then image height is going to be height multiplied by so image width divided by the actual image width. So we're gonna resize here to image width and image height. Height is not defined, right? Where is height? Height. Okay, here. Unknown resampling, nearest lasers, filter, use blah blah blah. Resize, and I guess we need to part this to an int. Oh, okay. So the thing I need to do is just to put this between parentheses. So we give it a size. All right. So now we have that stroke width text line. So let's take a look at the line method width. So we just put width here. All right. So just width. Great. Okay. So now we have it here, and you know what's happening is that we are drawing in absolute coordinates, so 1000 to 1000 pixel, but the image now is being reduced to 512 to something, right? So we can put that size here, right? If we print this, we see the image is now 512 by 401, and what we're gonna do now, so we're showing this image there and rendering it below, and what we're gonna do is we're drawing this thing, but now we want to draw the annotation. So there is a scale factor that we have here of the image. So this is like the resize factor, or like the scale factor that we're gonna also use to get to scale the bounding boxes, right? So we are gonna try now to draw a line for the bounding boxes, at least for the cross line, like the diagonal of each of the bounding boxes. So let me make this a bit bigger so you can read it better. And you know, we have here, I don't know if this has now theme. Right. I had never seen that, but this is gonna be better for my eyes. All right, so let's save this notebook that we haven't saved yet, and I'm gonna rename it. So dataset processing COCO 1.0 to YOLO v5. Okay, so this is something that I'll push online. So we have here this code. We were going to draw a line, but with a bit more meaning. So we have our scale factor, and we have the bounding boxes. So we have 2000 by 645. So that's the X and the Y of the first point. So the first thing I'm going to do, I'm just going to make a line starting from that point. So I have the bounding box here, and we're going to draw a line from the first corner of the bounding box, right? So we're going to get here. So we're going to get the, we probably can do this mapping here where we get the bounding box. X is going to be the 0, we have the 1, the 2, and the 3, and I believe, and I'm assuming this because I'm not 100% sure yet, don't remember. So we're gonna get, this is the X, this is the Y, and then this is the height, the width, and then the height. If we get this now, this is not going to, you know, it's on the, it might be on the corners or not, but it's not at the right scale. So we need to apply here our scale factor to scale everything. So scale the bounding box to the actual coordinates. And I think that should work, but I'm not sure. And also, I don't know about the y-axis. This might require us flipping so maybe let's put here image height. Maybe, I'm not sure. All right, so let's do one thing. Let's actually not resize the first thing we're gonna do is that we're not gonna resize anything, and we're gonna set the scale factor manually to 1 just to keep the original coordinates, so we know that the bounding boxes corners are working. So you can see that this is really working. So I don't know what these things are doing, but let's take a look at this. So this is XY, so X0, okay, X0, all right. So this would be better if we add those coordinates here, right? Okay, so now this is good. So now we have the diagonal of the bounding boxes drawn over our images, and we just need to draw the actual bounding boxes. So what we're gonna do first is let's apply colors. So we're gonna have here a set of colors. Let's say right now we just have 2 shades of gray, and here, depending on the annotation ID, we have annotation category ID. So all right, so we have this category ID, category, let's say category index. So we do this, and we're going to use that category index to get the color field. So colors, category index, and then we're going to get 2 shades of gray. So we're going to get 1 for colors is not defined. All right, so we'll run everything. Okay, so here now we're getting, you see, we're getting this red line for text and this black line for things that are drawings. And I guess that we could specify RGBs. So we could do 25500 and 0 to 550. We'll change this later. Right, and I think it's, yeah, that might not work. Yeah, so let's get rid of this cell we don't really need, and let's see our preview image. All right, so that's working. So we have our colors, and now let's try to draw the bounding boxes. It would be good if we can scale it. So let's try to scale it first, because that will make our development a bit faster. So let's see if the scaling works. So the scaling code that we did before is also working. So we can set the width to 3 probably. So we don't need it to be that big. Why are we now getting only 1? Huh, that's weird. It's interesting. Don't know what I've changed. And image width, image. All right, so let's get back. Let's try to fix that. So we don't get to resize, and the scale factor equals 1. Okay, so this is working, and if I set this one resize, I'm not sure if there is some caching that is going on in here. Well, let's just try to show the image here instead of displaying it apart from this window. Okay, so what's being shown there? Same thing, right? All right, so we have here, so we are scaling, so we have the image width. Let's print, oh, wait. One 1753. So 1753 2273 divided 2. All right, so image width, image height. And we're gonna do that. All right, my bad. So just a really silly thing. So I need to open the image before I can play with its height and width and stuff. So we'll put this thing here. I'll resize, so that's the right size of the image. And we are going to now get the code that I was doing before. So the original image width is this one. So our scale factor would be image width divided the original image width. And then the image height is still the image height multiplied by scale factor. And then we do the image resize to image width and image height. Right, so now everything's right? Yeah, so, okay. We don't need to print the categories. All right, so we have this working. We can maybe say we want 1024 to get this a bit bigger, or maybe, yeah, that we'll keep it there, and we're gonna put this to 5, so we get those. And we are gonna make the green color be blue. That way we will see it a bit better and run all cells. All right, so far so good. So we have this image here. If we uncomment this thing here, we can open the image a bit bigger so you can see it. And now we're gonna try to actually draw the bounding boxes. So we have the starting point. So we're gonna copy this one. So draw bounding box with corresponding tag color. All right, so we have the first line and we just want to do that. So let's see if that works, right? So that's the first one. And we just do this. So second point would be that one. And then the third one would be starting at that point and finishing at XY. Right, so that's our bounding box. So we can delete all the other code. We have our bounding box, and there we're gonna look for a polygon. So XY, a sequence of either two tuples like this or numeric values. So this would be a polygon. So we just call polygon fill outline. Fill, color to use for the fill, outline, color to use for the outline. All right, so now we change from this, we're gonna draw a polygon, and we'll start with this. And so how was the syntax here? Okay, so we provide an array of tuples for XY coordinates, and then we say fill non outline, and then we put our, so color was colors category, and we put here a color. All right, let's see if that works. All right, so we're getting the top line, so we just need to put the other points here. So that one and back here. We're missing one, so we go from here to here, from here to this one. One, two, 3, 4, 5. Okay, 1, 2, 3, 4, 5. All right, now we have it there, and nice. All right, so we've got there. It's been a bit slower than I thought. My Python pillow skills are a bit rusty. But okay, we could also have done a rectangle. I guess that would have been easier for this case. Well, let's try that. So we can do draw bounding box as polygon. We can do draw bounding box as rectangle. So I guess the color is shared. Get category color. And this, we can let's try this. All right, so yeah, and here we will do draw rectangle, and I guess we just provide 2 parameters, right? Yeah, so we just provide the same thing with less parameters. So we just do that and that. And I don't know, this has an outline fill with the line width in pixels. All right, so we do rectangle, and then we do outline color, and then we do width 5. And then we comment out the polygon. Okay. That, right. Yeah, so we just need to get this one here. Okay, so we're giving it the coordinates of the 2 corners. So now we have a perfect rectangle. And here on this parameter, we can adjust the thickness of the outline that we're getting. And probably not, doesn't accept a float. Okay, so this is our image here, and I'm gonna try now. I have to close all the ones that are open, and I'm gonna just try really quickly to do it with instead of just 1, maybe 3 images. So those will open, that one, this one, this one. Right, so we have interpreted the COCO 1.0 dataset format. So now we have the power to rewrite it to any other format that we want. And what we gotta do is take a look at the YOLO format, right? So we have a control over this. So we know that we have X, Y, so X, Y, and width and height. And we could do many different things. One of them is that we could get the coordinates in like relative coordinates. So absolute coordinates are these ones that are like pixel values. But if we do print, so let's say we print the X, Y, W height, right? So and let me avoid this re-rendering all the time. Right, what would be nicer, and let me just close all of these images. Right, what would be nicer here is that instead of having this, we had percentages. So for example, from 20% pixels on the width to 60%, and from 40 to 80. And that way we could apply that to any type of, so any size of the same image. And that is actually how YOLO formats are. So the formats are more in percentages more than in absolute values like the COCO format. All right, so, but in some way you can think that the COCO format is also providing you the relative coordinates, because inside of the schema, it gives you the absolute value of the size of the images. So at any time you could say, okay, I'm going to divide the annotation X by the width, and the annotation width by the width of the image, and the Y and the height of the annotation by the height of the image. And that's exactly what we're going to do right now. So you get here print Y, X, W, H, and here we could do this by image width, Y by image height, Y by image width, and height by image height. So now we print those, and you can see that this is 90%, 91% of the image to 36. So and 36, and then the bounding box size is 5% and 9%. How do we know that this is working? Well, I mean, at least let's take a look. So let's take a look at, if we have an image here, image width and image height, and you let me know if I'm slowing down, because my computer definitely is, and I'm not sure what's causing it right now. Let me disable this thing here. We're almost up to the 2nd hour of live stream. Let me see. So we're gonna All right, let's see. Okay, I'm gonna write a comment here. Yeah, I don't know if the stream is laggy, but this is definitely laggy for me. So I'm going to close things and reopen just to see if that solves it. One thing I'm gonna do first is I'm gonna commit the changes here to GitHub just to make sure that we don't lose anything. So I'm gonna put this live already. Right, something's definitely going a bit wrong. I'm committing this thing, so let me know if it's laggy or if it's okay. All right, and I'm just pushing. So the YouTube stream is telling me that there's something wrong. So I'm gonna stop streaming and come back to it. Okay, I'm back. Is this any better? Can you see me? Can you hear me? Can you see the screen? Right, let me see if this actually works or not. And if the computer slows down, I guess I'll restart or something. Is it good? I mean, can you hear me? Can you see me? Is it slowing down? Because I feel like something's slowing down on my end a bit. All right. Okay, so I'm not sure if you guys can hear me, but I think there's something wrong right now. Is something slowing down. So I'm gonna go and I'm gonna restart, and I'll be back in 1 minute or two. Hi. Okay, I'm glad I did that because I had forgotten to switch on the sound. So now we're back. So I would say if you can see me, if you can hear me, okay, we're back. We're gonna continue for a bit with this, and I'll, give me a thumbs up if you're online and if you can see that I'm here and you can hear me okay. All right, so I was mentioning that if you go to so github.com/nonoesp/live, you'll be able to find the notes from or the code from some of the live streams. Everything's not here yet, but you can see the notebook that we just been working on. You can see it in full, and this is just a way to render the annotations that we exported from CVAT into images, and we hopefully are going to convert those into YOLO v5 annotations. All right, so that was a quick recap. I am gonna open back the notebook. So we go, what you would have to do is clone that repo, and then you have to install Jupyter Lab on your machine. And what we do is we run Jupyter Lab in the machine that contains that notebook, and we get this Chrome tab or this browser tab in which we can execute that code. As a reminder, we have the path that we've obtained of the COCO directory, so where our images or our labeled images from CVAT are. We are getting the path of the images directory by appending the images folder, and then the annotations file by appending annotations instances _default.json, right? So if we run the entire thing, right, later we load the annotation JSON, we define or read our categories from that JSON file and define a set of colors. And maybe this makes more sense to go here. And we plot the categories here just to make sure that we've loaded them. And then we iterate through the images. We're just processing 3 right now. And we were visualizing the bounding box coordinates, right? If we don't print this right now and we just show the images, let's run the entire notebook. And what we can see is that the annotations that we had done on CVAT are showing up here, right? So we have the red boxes are recognizing or like displaying the labels that I've done for the sketches, and the blue ones, the ones for the text, right? So this is just a verification that this is working. What we were doing before is using image show on the Peel image, and Peel uses the system preview app on macOS to open that image. So we can, just see an example. I won't open the 3 of them right now, but if we open just the first one, we can see, we get high resolution version of that one image, right? And yeah, so for the people who are connecting that weren't here before, feel free to leave a comment on the chat, tell us where you're connecting from and what you're looking for on the channel. Or also join the Discord server and just introduce yourself. Okay, so where are we going now after we've got here, right? So we were saying, and this is kind of a quick recap on the trajectory of this, that we're doing data labeling with CVAT and labeling sketches. We're going to try to now prepare our data set into, prepare our data set to train with YOLO v5, and then train with YOLO v5, and then use that sketch detector that would allow us to automate the task of this thing that we had to do manually. So without further ado, let's actually take a look at YOLO v5, right? If you look for YOLO v5 on Google, you will find a repo like this one. So let me go to the right so you can see a bit better. So this here is this is the code that Ultralytics put together. So this is not code from the core developers of previous versions of YOLO. So if we look here at Darknet YOLO, This is some code that Joseph Redmond, as you can see, put together, and other teams, right? Other researchers. And if you go to the Darknet website, you can see a lot of code, a lot of versions of these things that use Darknet network for real-time object detection. But there was a continuation, or like I don't really know what it is. There's no paper for YOLO v5 yet, but there is a network and there is a repo on GitHub, and it works pretty fast for training and for inference, right? So this is what we're going to use right now. So if you look for RoboFlow YOLO v5, the RoboFlow team has put together good resources on their platform to automatically export data the same way that CVAT was exporting to YOLO 1.1 and COCO 1.0. RoboFlow can export to YOLO v5 directly, and that probably is a good practice or a good exercise that we could do at some point. So I'm gonna log in quickly to RoboFlow, and I'm gonna add markers here, or like notes to the chat and links channel here. So RoboFlow.ai, and maybe also a link to the Ultralytics repo here. Okay. All right. So all right. So we have here YOLO. Let me see if I can sign in. To RoboFlow. Right, so signing into RoboFlow, great. So this is, this is my account in RoboFlow, and I wasn't really thinking on taking a look at this yet. But upload your own data. We could come here, object detection, bounding box, annotation group, letters. I label this. Yeah, annotation group. So drawing. Yeah, I don't really know. Choose these by filling in the blank. I label all the drawings. Yeah, I don't really know. So given your new dataset name and annotation group, then click here to create a dataset. Type of subjects you're detecting, sketches, I don't know. Yeah, so I guess sketches. So supported annotation formats. So we can update of Pascal Bock, COCO JSON. And there is a good resource here, so how to convert to COCO JSON, and that probably is helpful. But this is the annotation format that we already have. So what would happen if we format, right? Like we can format the dataset that we have here. So we have a dataset in here, and we're gonna make like a so sketchbook to 1903 18 labels, for example, right? So we're going to get and take a look at the instances. So we're going to manually strip out the images that we don't have labels for. So we said that we had, let me just go to the bottom. So the last image that we've labeled is image 20, right? So I don't think we have image ID 21. We don't have it. We have 20, we have 19. All right, so if we go to image 20, right, we have some labels, but this is actually image 20. There is 20.jpg. So let me collapse everything here. And this is something that we could do through the CVAT UI, but I'm just going to do it manually here. So we're going to get up to image 20. and I'm gonna go, well, not 21, 20, and I'm gonna go and remove all of the other ones from this data set. So now we just have 20 images. And now everything we have to do is we just come to images, and everything after image 20, so including this one, we're just gonna remove. And when we have a copy of the dataset. So here we have 20 images and the annotations file. So I'm going to zip this file. So we could do it with the normal UI, but I have this automation here, and I'm just getting this zip file. So this zip file, I can probably draw unsupported files. Sorry, zip files are not supported. Restart the files first before uploading. Supported image format, add images and annotations. All right, so let's try first. So this zip file doesn't serve us. Let's try this. Select folder. All right, so select folder. Let me see if I can simply do this. This will upload all files. Only do this if you trust the site. Upload. Great. That was quick. After auditing all of your existing, finish upload. All right, so finish upload. So you can see here, we have the labels and we're previewing them, right? So drawing and text, and we can see all of them. And all right, annotations. So we're gonna click on finish upload. Now you can choose the size of your training validation. We don't really have too many images, but yeah, I guess yes. So this is getting uploaded now to RoboFlow. This, the good thing with this is that we might save the step of having to manually do the data processing, even though, we spend some time doing that. And now we can go here to, we can add a pre-processing step, so we can modify our images in different ways. But we're not going to do that right now. And we could also add an augmentation step, like to manipulate our images in ways that might help the data set. Bounding box level augmentations. Nice. These are really nice features, I have to say. Doing this manually is really time consuming, and these guys are doing a really good job. All right, so choose a name for this version or leave it blank. Version name. So let's just do this 18. So 20 images. Generate. Right. So now we have our label dataset on RoboFlow, and we could click here, say download zip to computer, show download code. Download code is if you want to download this from a remote machine that is actually has code to download and unzip a dataset, or in like a Jupyter notebook that you have remotely. So we can select a format. So as I said before, these guys are up to date and they have the YOLO v5 PyTorch format. That is the one that we're going to use. And it exports TXT annotations and YAML files configured to use with YOLO v5, right? We click here, we'll go to that, probably that RoboFlow object detection tutorial, right? So when we click continuing here, so they make a zip file, so they process our data into that format, and then they just download that file. And then this file here contains the necessary data for us to train a YOLO v5 model, right? So we have here, the RoboFlow that tells us what it has done with the data set, the data YML file, which just has, the directory of the training and validation images, the number of classes, and the names of each of the labels. And then we can see here, as you can see, the test images don't show up on that file, and that's because those shouldn't be used during training. Those are for like testing after you've trained the model. And here we have All right, so yeah, and for now we have these images, right? So they have these images here that have been resized to 416 by 416, and then the corresponding labels. So for each image, right, they have unique names. So there's like 01 JPEG and then a hash there, or like a unique ID. And then these are the corresponding labels. These labels, and this is interesting, right? Like we had what we had to get from here, we had it before. So it wouldn't have been that hard for us to generate this data set, but at least we can verify how it needs to be, right? So when I was here on the notebook, we were rendering this image, right? And what you could see if I print again these three numbers, right? If we look, and let's hide this image from here. So if you look at this line, let's zoom in closely, right? 91, 36, 5, and 9, right? What does that look like? 94, 41, 5, and 9. So it's not quite the same. It seems there has been some change there. I don't know if it's because of the resizing without padding. So one thing that happens is that these images have been resized without padding, and sometimes you can add padding to them and might make these things change a bit. So let me see why that is. So is this image the same one? So is it the first one? This is the first image, and we're seeing here that first image. So we have 91, 36, 56, 94, 56, 49, 09, 01, 413. Yeah, so these are not exactly the same, and I'm not sure why that is. So converting YOLO, so COCO JSON to YOLO v5. But yeah, okay, so long story short, in here we have file, and then we have the annotations, right? So we have all the annotations that correspond to that file in YOLO format. And this is in summary, right? This is all we need to train YOLO v5 with this dataset. So there is a Colab notebook here that I'm gonna put in case that you guys want to do something with it offline. So RoboFlow PyTorch YOLO v5 training notebook. I put that on the Discord server, and this would be it, right? So we would just have to and we can width of bounding box. Yeah, I don't know. I don't think it's the width. And Rob, I can see a comment here. Does it make me a software pro if I click on that dialog box you just showed? What does that mean? I don't exactly know in what context that comment was shown. I'm just like reading it after the fact. So what do you mean with that? I don't think the width of the bounding box is what's happening here. So one thing that we can do that I'll try right now is that if I go here, and I'm gonna move because there will be like a unique, well, I don't think a lot happens there, but so here we can click on generate, right? So we have our data set, and let me see if there are public sharing versions. Yeah, so this version, if I want to get a link, I will get, do not share this link beyond your team, that's your RoboFlow account. Okay, so how do I go here? All right, the key. All right, so V1 has that link, V2 has VNO to SKQ. Right, yeah, so okay, so the link I showed, that's unique and you shouldn't show that, but I'm showing it live. It doesn't really matter because a dialog box looked too real on the stream. I thought it was from YouTube. The dialog box was on your screen on my... Oh, okay. Yeah, I don't know. I think I zoomed in really big and yeah, it might have been a bit confusing. Zooming is over if I click. I see. Yeah, I understand now. Okay, so we have this code here, and what the RoboFlow's guide do is that when you have to clone your data set here, they just provide you with code that you can change here, right? So this line of code here, I can just copy paste this, and that will allow this notebook to download, right? I'm gonna try now and see if this works, and the only thing I'm gonna do is I'm gonna try to set this to train, but not for too many epochs, because I don't want to have to wait to see results. And I don't know for how many epochs this trains by default. Epochs 1. All right, so right now it just says 1. So let's just try to get GPU, and let's try to run all. Yeah, I think the guy who's preparing these notebooks is this guy. So it's Jacob at RoboFlow. So they have a bunch of videos online that you can also watch for tutorials on this. And yeah, so I don't remember the name of this guy, but yeah, so these are some of the videos they have. They're really useful. Okay, so let's see. We're training, so we've kind of skipped one step by using RoboFlow, not to have to process the data manually, but we'll have to figure out how to process the data set properly in order to get that done. All right, so then this is there. Okay. All right. So what this has done, so a few things that this has done is it's mounted my Google Drive and saved the best model to the root of my directory. So this is in this case it's a 14 megabyte file that is on Google Drive that I'm going to download right now and delete. All right. So I'm going to create a folder called ML. Okay, and I'm gonna RoboFlow custom, and we're gonna save this to my drive ML. All right, so let's see if that works now. Yeah, these copy commands to OneDrive sometimes take some minutes to complete. And yeah, we have here the YOLO PyTorch model. So this is the model that we have here, and this would be a model that already can make predictions, but it would be really bad because we haven't really trained more than one epoch. So it will be like a dummy model. All right, so. And also the dataset is super small, so we're gonna have to do more data labeling there. All right, so what else do we have? So we have this, and I think this is fairly fast. So on the epochs parameter, we could put maybe 50 epochs and see how much time that takes. So we're gonna run all again. All right, so that is probably downloading the dataset again. So downloading, configuration we'll use for our tutorial. Oh. All right. All right, and you can see how fast this is. So this is actually training epoch per second, or like 2 epochs per second. Yeah, it's 1 epoch per second, more or less. It's really fast. So we're gonna have a trained model really soon. But again, like we don't have many labeled samples, and this is probably not gonna be like a super performing model. But I'm excited. So I think we can try to run it on some of the samples that we have and see how it performs. Some of the samples that we have that we haven't labeled yet. All right, so we have the model now, and I'm gonna check on Google Drive. So Drive.google, we are at hour 2 and 40 minutes of the live stream, so we're gonna probably stop soon. I'm glad that today I had some more time than usual. Okay, so where are we? Yeah, so you can see here the MAP is going up, but I don't know up to what value. MAP smooth recall. So loss going down. It seems, you know, we need more objectness, classification, precision, ground truth training data, and ground truth augmented training data. And then display inference on all testimony. This looks much better with longer training above. Image glob, run detection, assuming JPEG. Right. So here we have YOLO v5 runs train 2. So this is our second train. So this is a prediction. And there are no bounding boxes here, which, you know, it's super weird. It might be that we don't have enough. All right, so really quickly, just in case this suddenly works, but I don't think so, and we don't have time to look at it right now. So I'm gonna clone the YOLO v5 notebook, so repo, git clone that, and then we're gonna go into it. And we need PyTorch, so I think I already have an environment with Python installed. So we're gonna do torch, so conda activate torch, Python 3, import PyTorch, torch, no model import torch. All right, so it seems like PyTorch is indeed available. Great, there it is. And in here we have the detect file. So we do detect.py, and if you look at it here, so this is a detection. We have all the parameters here. So we have the weights, so we'll provide the weights file, which is at downloads, and then best.pt. I don't know if there's another. Yeah, so best.pt is the one I just downloaded. We have the image size 416. Let's see what size. Yeah, so image size, batch, epochs, data. Weights, no weights, results, cache. All right, and I guess we just need to input the images. So we just input the source. So we'll do source, and then we'll get the folder of images that we haven't really gone through. Well, I'll probably just provide all of them. 18 labels. Just put this here. Desktop images, and then save results to project name. Project test 01, so detections 01. Save results to project name, save results to project name. Yeah, I don't know. Okay, so name sketches 21903. All right, let's just try that. I don't know if it's gonna work. So I'm executing that. It's the default detect.py script over a set of images. So it seems it's now running over all of those images, and it's resizing them. And who knows where it's putting them. I don't know it. Oh, okay, so it will be inside of the YOLO 5 runs, probably, a detection. Okay, detection 01 sketches, and here. So yeah, it doesn't seem like there are any bounding boxes being drawn, and I don't quite understand what's going on. But we'll have to debug. So there's something missing here that I'm not fully getting. But, you know, I would say something. So the dataset looks good. So it seems like the labels and the augmented labels are on the right place. So 0 and 1. And those should be good. But there is something weird here with the predictions not showing up anything. So we have drawing and text. We have a train folder with images. It has 20 images. But the MAP doesn't seem to be going up at all. So yeah, this is one of those things. I need some more time to take a look and see what might be going on. Train young time its performance. All right, let's actually just do this. So let's just retrain on more epochs and rerun everything below, just to make sure that it's not, because it's not, you know, because we're not training for longer. train batch 0, YOLO v results, and train YOLO v5 runs, train results, and then this one. Okay, but what about the second one and the third one? Train batch 1. So let's see. Okay, so this is good. This is working, but I don't know about the right, so this is a report on like the bounding box sizes, the height of the boxes, and how many classes, if they're balanced or not, and where they are. And yeah, so now we're waiting for 200 epochs to complete, so we're at epoch 60. And yeah, so this is gonna take like a few seconds to complete, but this was fun session, I think. So we've covered a lot of ground today. I hope you've learned something as I did. And I just wanted to thank you for watching, for being online with me while I do these things. And yeah, I would be willing to hear, like, if you have any questions, if you learned something specific today or in other videos, let me know. Let me know on the comments, or let me know on the Discord server, because you are a big part of this project, like the people who are watching. And I'm the first one who's learning here, and I hope that you are too. So yeah, I would encourage you guys also to ask questions, ask questions on the YouTube comments or on the Discord server, things that you would like me to try to talk about on the live streams, like other topics that you'd like for me to cover, or things that you would like for me to like maybe respond to or do some research and then talk about. I would be also willing to make a one-on-one call. So if anyone is interested on making a not a one-on-one call, like a Q&A session, like maybe we can all join a Zoom call and like have a chat and get to know each other, because I know, for example, you, Rob, are online, and we've talked on LinkedIn or on the Discord server or here on the live stream, but we haven't met face to face, even virtually. So or like same thing for Pedro, I know that we talk on audio at some point, but we haven't met. So if you guys would like to do a Q&A, just let me know on the Discord server. We can talk about it. We can schedule it for when it better works for everyone, and we can make sure that we get as many people there to get to know each other and to collaborate in our learning efforts. I would give a shout out here to Gant. I think he shared this is the Discord server for those of you who don't know about it or haven't visited. I will give a shout out to Gantman, right? So that's Gant Laborde. He just got a book published. He's probably been working on this for a lot of time, like years maybe, I would say. Learning TensorFlow.js, powerful machine learning in JavaScript. So there is a tweet, and there is a link to Amazon. I'm not sure why this is #1 release, but there is no book available. It's temporarily out of stock. I don't know if it's because they ran out of stock and there is no Kindle version. But yeah, so this is Gant Laborde, Ruby Motion App Development, all formats. So he's probably his second book. But yeah, I will give a shout out to Gant. Thanks for sharing on the Discord server, and we'll be taking a look at the book. Okay, so this now I'm gonna delete. Well, not gonna delete it yet. This is finalizing, so this is at epoch 192, and I'm gonna start closing stuff, so making sure that the notebook is saved and we push it to GitHub. So we're gonna stop this, git status, git add, dataset. All right, so as I said before, oops. At github.com/nonoesp and live, you have the notebook that we used today for rendering the CVAT COCO annotations. Another shout out before we try the model and then we wrap. New episode on the podcast with two friends, Es Meloni and Selene Urban. You can listen to it on the website, or you can listen to it on Apple Podcasts or Spotify or YouTube. It's, I don't know, I had fun. I learned a lot. This was recorded a while ago, but we just edited and prepared for publication over this past month. And yeah, I will encourage you to listen if you want to learn more about how to connect with your audience, how to be authentic in some way that I try to do that, and how to overcome the fear of meditation and get introduced to breathing practices and so on and so forth. All right, so we should have the model trained by now. So this is here. I don't know if it's gonna work. Probably we can see if it works or not just by looking at the results here. So it seems MAP is still super low, so that this doesn't seem like it's gonna work. Precision is really bad. Box. We're on the red and it seems it's really similar to the blue. All right, so there is something that has to be wrong in here, because there's nothing that is being recognized. Zooming JPEG. JPEG. Might that be a problem? JPEG? No, I don't think so. All right, if anyone has any ideas, let me know. I would love to hear about them. And yeah, I'm gonna disconnect now. So thanks so much. I don't know if I have anything else here. So this was Nono Martinez Alonso. Thanks a lot for everyone who connected. I really appreciate you being there. I will just say that thanks a lot for watching, and that I'll see you next time. Bye. Thanks a lot. And yeah, thanks Arthur. I will thank Rob has been here today with us. Arthur has been here today. Mamadou, Jose Luis García del Castillo, which I will encourage you to watch his channel as well. Lourdes, Bea, Pedro Cortez. Thank you, everyone. I'm off now. Have a good day. Have a good rest of your week, and I'll see you next week.